Okay, so we're actually starting today, which is 8.5 applications, day 2, by grading last night's homework, and I want to talk through how these problems should have been done as part of the lesson for today. That's why I'm recording. Normally I don't record the homework, but here's how I want you to think of these. You have your start amount, then you times by e to the kt, and then over here you have your end amount. Well, they gave you stuff, so everybody's grading number 14 here, and some things I'd like you to look for. First of all, the start amount was 50. They should add a 50 there. The time was right there, 5.27. Be nice if they had it in parentheses, but they don't have to. And then the end amount is, since this is a half-life question, that should be 25. That's worth 1 point that they set that up properly. And I believe I did that in class, so that should be an easy point. Next, what you're supposed to do is to find k. So basically solve that thing for k. So then the first step is divide by 50, and then this is a half equals e to the 5.27k. Now how do I get that k fixed? This goes to our number one strategy, which is rewrite. I'm going to rewrite this as a log base e of a half equals 5.27k, and then to get the 5.27 off of there, it's just a multiply, so I divide both sides by 5.27. They can say 1 over 5.27 in front if they want. Final answer, k is that. That's the second 1 point that I want you to check for. I have that. So far they've got 2 out of 2 then. Now, I want to clarify though, just so you guys get, that's not the whole goal, is to just solve for k. The whole goal is actually to write an equation. I'm not going to grade this on the first problem, but if we had gone further, your next step is always to go back to the original equation, which has got the start and then the e and the kt and then the end over here. And you go back in and put in the things that are unique to this problem, like the starting value was 50, and the k we have figured out. That's really messy, but goes right there. ln, I'm going to use that for log base e, 1/2 divided by 5.27. Why is this equation so powerful? I'm going to give it a better name than end. I'm going to call it the amount, a of t, because now this equation is equipped, that's the thing we're really looking for. It's an equation that's equipped to take any time and just stick it in and use a calculator if necessary, and you can find out how much of the stuff is left. Or instead of them telling you the time, maybe they'll tell you how much of the stuff is left. Like, oh, 90% of the stuff is left, which would be 45. You just take 90% of 50, and you put the 45 there, and then you can solve for t. So this equation is what you're really looking for. Solving for k is just like a precursor to the actual big final answer, which is this. Again, I'm not looking for this in problem 1. I'm not grading it in today's homework, but that's what you're really looking for. I just don't want you to think it's all about solving for k. It's all about finding k and then sticking it back into the original equation. Okay? Do you get that that's the master equation? Because all it has left is t, and it's like x and f of x, or t and a of t. Okay, so moving on. In this problem, I would have expected them to set up the original, which would be the starting value, which is 1, times e to the k t, and the time in this case is 704, but do you get, I just rounded a 704 million to a 704? And so technically I'd have to say in millions. I'm not going to make you mark it wrong if they don't have in millions, but if you just put 704 there, you just said it was 704 years, not 704 million years. Maybe you should put all 6 zeros after it, or you say in millions. Again, I'm not going to be as tough as marking that off, but I hope you notice that. Okay, next thing is, it's supposed to give me the end value. And since this is a half-life, what's half of the 1? 1/2. That equation right there, or the next layer of it, which would be to get rid of the 1, and it just looks like this. Either one of those is okay for 1 point on this problem. The next step is to actually find k. Now, if they didn't have this And I think they just copied the answer key. Okay, so I want them to lose the point if they don't have this. Okay, well, I don't see how you would get the next step, which is what K is. Maybe copy it from a friend, whatever. But I want this there. If that's not there, they lose a point. You got a question?
They left a 1 in that answer right there.
That's okay. Like I said before, it's okay to have a 1 there. All right, so now we're going to actually get the K. And so I'm going to go log base E, also known as ln, but I'm going to use log base E of 1/2 is equal to 704K. And I want the 704 off of there, so I divide by 704. And there's K. But this time, I'm not going to give the points for that. This time, I'm going to give the points for this part of the problem, which says find the function which gives you the amount in terms of t. So we have to basically do what I just showed you on the last one. Put this into the other equation, which is a of t. I really don't care what the variable a, could have just used a, that'd be okay, is equal to the starting amount, which is 1. In this case, a 1 doesn't even have to be there because 1 times anything is just itself. E to the k, which is now this, ln, or log base e, 1/2 over 704 times t. That's the master equation. That's what they really needed to get the point on this one. Okay? So 1 point for having this and 1 point for having that. Any questions? Something like that, but it's not quite right and you want to know what to do? Okay, so then we have graded 4 points so far. Now the last point, okay, question, yes?
Yeah, 0.1 equals each, but I learned 0.5 or 0.4.
Okay, this is 0.1, it's supposed to be 1/2. And then equals what? ln. Okay, I think there's too many mistakes in that one, sorry. They can always talk to me later if they think it's right and I'm just not understanding. All right, so we've graded 4 points. The last point is, did they finish? The only other problem there was, oh wait, on this part, they did have another part that I didn't grade. They should have tried to figure this out. And again, 90% of it means you'd put this in as 90% of 1, which would be 0.9. They stuck that in and solved it. And anyway, that's to finish this problem. And then the last problem we'll check is make sure that that was a skip, that they do this one. And if this problem is completed, then they get their score out of 5. We will later double it, but don't double it now. Just give them a score out of 5. Any last questions? Okay, we're done grading that. Get back to your spots. So now we're done with that part. We're going to the new stuff, which is on compounding of interest. I'm going to pause for a second while you grab your graphing calculators again. Okay, so there are 2 major formulas that you need to know for compounding interest. One involves a certain number of compounds per year. Let's say, gentlemen, with me, let's say that your number of compounding per year is monthly. Then what do you think I should put in for n? 12. If it was monthly, you'd put a 12 there and there. If it was daily, what do you think I'd put in for n? 365. That's for daily compounding. So that's how that formula works. The rate, let's say it's 8%. Why am I making it 8%? That seems really high. Well, it's called an interest rate, but it could be an investment rate. And 8% is typical of the stock market over the long haul. And I want you to hear what I just said, over the long haul. Does that mean that if you put your money in stocks, you get 8% this year? No, you might get 20%. And then next year, you might lose 12. And then the following year, you might get 16%. And then the next year, you might lose 4. I mean, it goes up and down and up and down, but on average, stock market averages about 8%. Could there be 3 years in a row that are really bad? Yes, we've had that before. But then usually the next 6 years are really good. So on average, 8% that's where that number comes from. Okay, so that would be like a 0.08 going in here. And do you understand what principal is? It's the money you put in. If you only have $1 to put in the bank, it will grow, but it'll grow very slowly because you didn't start with much. Okay, so principal is your starting amount. Notice it's in the spot where starting goes. Get what I'm saying? The other equations always had the starting amount there and the ending amount there. Same here. The ending amount is A. It's the amount you'll have when you're done. All right, so would you please just put in these numbers, 1,000 in the principal, and we'll figure out A using, let's use 8%, and let's do the monthly compounding. So hopefully you know what to put there and there. And let's do it for 10 years. Just seeing if you can put that into a calculator, first into an equation, and then type it in your calculator. We're doing 10 years, monthly compounding, 8%, $1,000. Now, this is important. Do you get from the order of operations that this 0.08 divided by 12 is going to be done first? Unless those parentheses here, which there aren't, that's going to make that part get done first. And the reason that it's such, all of a sudden this 0.08 divided by 12 is really small, but then you're getting it monthly, so you get 12 times that number of years, because you're getting a total number of months that it's going to compound instead of years. So I know this gets to be really small and it feels wrong, like it's not growing by very much, but it's doing it for way more than 10 years. It's doing it for 12 times 10 is 120 times you get to grow that way. Yes, sir. Yep. Good question, because we're not solving an equation. When you're solving an equation, you have to move stuff to the other side, and like if I have a +5, you'd use a -5 to get it over there, right? This is not about solving an equation. All right, we are just typing stuff in, and we get a final answer, and who's got it and feels like it makes, they feel confident that they probably did it right? What do you think? We'll see how many people agree with you. 26, what? 09? Can anybody verify that number? Oh, a bunch of people did not get that number. Who's got another number that they think might be right? I mean, I can type it in the calculator, but I'm trusting a bunch of you probably typed it right. Yes? Who got that one? Okay, that's a lot of people. Would you please read that one more time? 2219.64. All right, can you try retyping yours in and see if you can get that number to come up? Yes. Calculator issues? You want a different calculator? Since I'm recording, I'm not going to be able to help you right now, but you can check with the kid next to you, or I borrow one of my calcs. All right, so we need this $2,219 is to understand like what it is. That's your $1,000 that has grown over 10 years. Now I know that seems pretty small, and it is pretty small. Yes, it doubled. Your 1,000 became 2,000. But here's what I think is a more realistic scenario of how you should do this. The A equals PE to the RT formula. This page is getting really messy, so I'm going to make a new one here. Amount is PE to the RT. That's a much cleaner formula, and it works really well for what's called continuous compounding. That's the kind that the banks use. They almost never use monthly compounding. Granted, there's monthly payments a lot of times, but compounding is much more often done with this formula in the real world. So PE to the RT is my formula for continuous compounding. So you have two problems today. One kind will say, oh, it's compounding monthly. And you got to use that formula we just did. If it says compounding continuously, you use this formula. Now I'm going to give you a new scenario that I think is one that is compelling for you to understand, to see, for your real life. Imagine for a couple of years you come out of college and you've got your real job and money's starting to stack up, because it does, because you don't have that many expenses, you don't have any kids to like pay for yet and stuff, and you got some money sitting around. It's going to be very tempting to spend it because you're just the first time getting money. Okay, so let's say that you, after a couple of years, have piled up 20 grand. I know that feels like a ridiculously large amount of money to some of you. But if you have a real job, that is a very real possibility. Even as a teacher, you work for a couple of years. If you're careful and don't spend it all as you get it, like, ooh, I've got 1,000, I can spend it on this. If you just pile it up for a while, you could have 20 grand. That's your principal. I want you to try to put this in the calculator as I say it to you. You have 20,000 and you're going to do continuous compounding. In case you can't find E on your calculator, it's above the divide key, I believe. P times E to the RT. Well, what's the rate? I just told you a second ago that the rate is 8%. That's what I want to use for a standard stock market growth rate. I know that doesn't mean every year. I'm saying on average. And then time is a really important one. Do you get out? My scenario was you just graduated from college, so you got a long time before you're done working. You very well might have a 50-year period from the moment you start working to the moment you're done, because that would make you like 65, 70 kind of zone. Okay? And I know you might be thinking, oh, I want to retire before that, but the direction right this minute, they say an average person like me is going to work till they're about 67. And as you get to your age, you're probably going to work to 70, because that's just the trend right now is everybody's living way longer, and you can't afford to spend half your life in retirement. Nobody seems to have that much money. And granted, if you save a ton early, you might. But I'm just trying to tell you, it's reality. Most people nowadays are retiring a little bit later than they used to. And so it's very possible you'll be working till you're 70. Just got to enjoy what you do, and it's not that bad. So if you have 50 years for T, again, I know you think right now that that's a ridiculously long amount of time, but it's basically your whole work life. Would you please figure out what the 20,000 would grow to at 8% for 50 years? Not 91,000. Must have done something wrong. 1,091,000. I'm rounding a little bit, but over $1 million. Now, some thoughts on this. This does not mean you never spend money for the rest of your life. It means you gathered up your little nest egg and you put the 20,000 away and you didn't touch it and you just let it grow. And for the whole rest of your life, you could spend along the way. You just can't touch that 20,000. But all the extra money you're making that you piled up in the first place to get that 20 grand, you can start spending it then. And you can keep spending it the whole rest of your life. If you just don't touch that 20,000, it alone would grow to $1 million. Now I know some of you might save up another 20 grand a couple years later and stick that in the bank. And it doesn't have 50 years to grow. Maybe it only has 48 years to grow. But you'll have 2 stacks of money. That'll be worth a lot. And somebody else will do this every 3 years. They put 20,000 into an investment and they have a whole bunch of little piles of money at the end. But most people, most Americans will get that 20,000 and then they'll say, "Ooh, I'd like a new car." And poof, their 20,000 is gone. And then they saved up another bunch, like maybe they got up to 10 grand this time and they're like, "Oh, but I'd really like a boat." And they spend the 10 grand, poof, and now they have nothing. And then they get to about age 50, which is my age. I'm 49, but getting close anyway. I can round myself to 50. And then they say, "Okay, I got to get serious about this." And they save up that 20 grand and they stick it into an investment. Would you please change it from 50 years, because now I don't have 50 years anymore. I only have 15 years left before I want to retire. And look at how much I would have if you change that last number from 50 years to grow to only 15 years to grow. Most Americans don't get serious about saving until they're 50. Do you get why they get so little compared to the people that did it early? It's the same 20 grand. Do you get the difference? You're going to have to give up 20 grand. Would you rather give it up early and then have $1 million at the end, or give up your 20 grand when you're 50 and only have a little teeny tiny bit? And the other thing that's psychological about this is if you're at the end of your retirement and you've only got 60,000, and by the way, that would still make you above average. If you only had 60,000 when you retired, do you get how you're going to be kind of paranoid about your 60,000 because like that's your only nest egg. Like if you lose that, you have nothing. Like so you want to save it in case of emergency. Whereas if you have $1 million, you're going to feel a little more free to be generous with your grandchildren, and you'll be able to buy nicer stuff. I mean, you can't go crazy and spend all $1 million in your first year, of course, or it'll same concept, it'll be gone. But you can have a much more fun retirement someday. And if you're that teacher who's getting sick of teaching, you'll be able to say, you know what, I'm retiring early because I got enough money in the bank. And you won't torture children for your last 5 years of teaching because I can't retire yet. Get what I'm saying? This gives you freedom to be able to quit your job and not torture people by staying there if you're not really doing a good job anymore. So I encourage you to think about being the person who puts the 20 grand away early and has the nice, fun retirement, as opposed to the person who waits till they're 50, which is my age. It's not like way over the hill. And start saving then, you won't be able to build up much. Granted, you could save more, like you can save 20, maybe I could save 50. Well, still, you try sticking in, you don't have to do it, but if you stick 50 in there, if you only have 15 years, you won't be able to catch this $1 million amount. You just can't do it unless you put away like 50,000 every year for the next 10 years. Okay, but that's way more painful than that person who just had to pile up a stack of money when they were young and then save it. And there will be many people who will get close and then they'll just spend it. And I understand. I get it. It's fun to spend money. All right, so you will have a choice to make when you're 23, 25, and I'm just encourage you to go that way. You don't have to do exactly 20,000, but the principle is do it when you're young, and it piles up a lot better than when you're old. Yes? In my first year of teaching, I started saving. I put away $4,000 in my first year of teaching out of my paycheck. And it's not like I was a first year teacher. I wasn't making a ton. But I put 4,000 in that first year. And then ever since then, I've been saving every year. And so, I'm okay. I'll be fine. I'll be able to have a retirement that's, got fun things in it. But I do know people that are my age that have only just started. And that means that it's going to be a lot harder for them to have enough to feel comfortable in retirement. Yes? This was assuming stocks, yes. And if you're not smart enough to pick good stocks by yourself, which it's hard to be that smart about exactly what's going to go up, then you can just put it in what's called a mutual fund. And that basically means that somebody else will pick the stocks for you. It's like a smart guy picks all the stocks, and you just put the money in, and he automatically picks the stocks for you. So you don't have to be a wizard on exactly what stocks to pick. Well, there's even things that just there's funds that you can buy, like with. Have you guys heard of like E-Trade or Scottrade? Well, there's a lot of different brokerage places where you can just buy their ETF. It's called. Once you're this age, come and talk to me. I'll tell you exactly what you could buy. That's an index fund. And basically, it just buys every stock in the stock market. So instead of having to like try to guess which ones are going to go up, ETFs can buy every single stock. And then as the whole stock market goes up, you go up. Even if some of your stocks go down and some go up, on average, you'll go up with whatever the market goes up. And those also have very low expenses too. But anyway, long story short, the main point I'm trying to get across here is if you start early compared to starting late, you get a much bigger paycheck someday, or not paycheck, not much bigger account balance to play with. Sir? The money that you started with, you built this up and you have this in your checking account. Then you have to actually invest it in something because a checking account is going to get you like 0.1%. So that's where you start a separate account. And sometimes, like I know at Wells Fargo, for example, that's where I have my bank. If you want to, you can take your money from your checking account and you can put it into a wealth management account. And so basically they just start a different account that actually can go into stocks. So it's not hard to do. Once you got the money, you walk into any bank or any place and they'll be happy to tell you, because they want your business, how to put it into stocks. So this is not meant to tell you exactly what stocks to buy. I don't know, and it's more complicated. I could probably spend an entire hour on exactly how to invest. But the main moral is you got to start early. And when you get that age, you talk to smart people, read some books, you can find out the best ways to invest that money. But starting early versus starting late, huge difference. Okay, so your homework for tonight is, one more thought. This is kind of a cool one. The law of cooling. This is kind of morbid, but if you die, you start to cool. Think about that for a moment. So when they find a dead body and the person is warmer than room temperature, because once they hit room temperature, just think about that for a second, aren't they going to stay at room temperature? Your body doesn't keep cooling below room temperature and you're becoming like an ice cube, right? You just go to room temperature. So if they find a body that a person has died, they can, based on the temperature that they are when they are found and the room temperature of the room that they are in, they can tell how long ago the person died. Now, in the case of a natural death, like the person died from a heart attack or whatever, it doesn't matter that much exactly the moment they died. But what if it's a murder? Then it matters a lot when they died. Because if they can figure out that the person died at 11 p.m. and their main suspect has been proven to be, with their friends at the bar at 11 p.m., well, then their main suspect can't be the person, right? So knowing exactly when the body, when the person died is important. Just so you know, I'm just going to say it's the same kind of formula, e to the kt. That's the formula that they use right there to figure out what the temperature of the body was. So I'll just get that kind of started in your head, and then on Monday we'll do one of these as a practice problem for you. But I think it's kind of cool that the same power function is used to tell how long the person has been gone. I think it even works if it's like above room temperature, as in, why would that be? Let's say you're in Arizona in a room that's 110 degrees. Well, then when you die, you're actually going to heat up. Kind of a weird thought. But all that matters is the difference between it's not you, the body's temperature and the room temperature. All right, we'll do one of those on Monday. All right, so let's find your homework here. It starts on day 2, and I'm going to try to keep it reasonable. This first one is really pretty easy. It's just saying you got $1,000, 1.25% monthly. Do you get which formula you're supposed to use? The one with the N in it. This one is $1,000, 1.25% continuously. I'll help you with this one. A equals, this one was a snappy little name. You remember it? PERT. P, E to the RT. P times E to the RT. Sir? You can look it up if you just scroll up a little bit. It's in your notes, I promise. That's on the page. All right, moving on. I want you to do this one. You don't have to do this one, of course, because this is optional. And then we're going to do one last one because I want you to see it's not always about money. This one's about how many wolves there are. And that's the last one that we will do. So you can skip the rest. Okay, so go up and including the wolf problem, and then that's it for today.